So we've got our first speaker of the evening. It is Mr. Daniel Lewis. In recent months, Daniel's been immersing himself in 3D printing, and he's going to discuss the trials and tribulations that he's come across, a bit about building your own 3D printer, making your own upgrades, 3D printed cheese.
Yeah, stuff like that. Maybe, well, maybe.
Awesome.
Probably not today.
Not today,
Probably a
next year.
project.
Dan works at HeadForwards. HeadForwards is an outsourced development company based down in Poole. They're a really awesome group of people to work with and work for, and I believe they are hiring at the moment. Is that right, Lissa?
Yes.
So get in touch with Lissa or Dan or Toby at the back there. Probably best Lissa, and she can tell you more. Without further ado, Daniel Lewis.
Okay, so this is about my kind of journey through 3D printing, not about the technical side of 3D printing specifically. Where did it begin? So I kind of heard about it in college, like way back in 2009 or something, when I just kind of got into tech as college level, planning on going into it through the rest of my life. I did a little bit of research. At the time, the one on the right there is what was kind of standard for home-built ones. It's called a rep wrap. Mendel, I think that one is. It's homemade, open source design. This in the middle is a more expensive production model. The Ultimaker is like $2.5 grand, and this one here is a different kind of printer. That's an SLA. So I'll be talking about I've got an FDM printer, which is fused deposition modeling. Just melts plastic onto more plastic, basically. This one here cures it with UV, but they're a bit more complicated, and you probably can't do them at home just yet. Why did I want to do it? Well, I play a lot of games, both tabletop and not tabletop. Computer games, Halo, for example. I'm planning on printing a Master Chief helmet, but I haven't quite done that yet. And also, I could build a load of terrain for Warhammer if I wanted to. Not just terrain, probably models as well. At this point, the prints are actually getting pretty detailed. So it all happened in the end of December when at work a colleague of mine sent me a link to this printer. It's the ANET A8. It's exactly the printer I've got. I got it for £130. It comes in a kit form, so you have to build it yourself. I did a little bit of research before I bought it. It does, in some cases, catch fire, which isn't particularly useful. But I just bought it because I've been looking at them for years, wanting to do it. I just thought I'll take the plunge and do it. So I did. A little bit, well, literally an hour later, I bought one. It's kind of came through in the post about a month later. But Simon, the guy who linked it to me, decided to also buy one. Like an hour later, and then as things do in a workplace, when something's cheap and seems like interesting and we can start a new club, a few more people bought them, and of course there's always one who wants to go and buy the official one rather than a knockoff. So the next thing I realised was I'm going to get a printer through, but I'm not going to be able to print anything because I don't have any plastic. So I did a little bit of research, and the amount of times I made a mistake or looking at something like, oh, this is nice and cheap. No, it's the wrong size or the wrong kind of plastic. So I tried to focus on PLA, which is polylactic acid. It's just a normal, low temperature, biodegradable plastic. It's the stuff they make Tesco bags out of. I got 3 different plastics. I got 2 cheap Chinese eBay purchases, tenner each for a kilo of plastic, and 1 sample of and a couple of samples, free samples from Rigid Ink, which is a UK company that do higher quality filaments. They're more like 30 quid a kilo. So it did come through. Slow boat from China. It took about 20 days. Building it was fun. I'd never done any electronics project before. Pretty much never made much with my hands, really. I did a bit of woodwork in school, but school's about as far as it all went, really. Putting it together was nuts, bolts, plastic. It's pretty easy. Wiring it all up was fun. It's just badly labelled, sometimes wrongly labelled plugs put on it by obviously a Chinese factory worker that didn't know which ones they wanted to go on. But it all went together smoothly. This last picture here is me turning the printer on for the first time and getting some dampen. I might ruin the joke a bit. Calibration is really complicated. Requires two really complicated tools, but the clicker ruins that punchline of my joke. It's a piece of paper and a screwdriver. You put the nozzle right down to the bed, slide some paper under it, and adjust it with a screwdriver until it just about touches. I thought that was going to be the most complicated part of the whole printer build and getting it together, but it took 4 hours for me to build it, 4 or 5 hours for me to build it, and then about an hour of setting up, a few minutes of configuration, and I was on to my first print. Which is this. I've got it at the back. It's been a bit warped by the sun since this, but it was much better when it happened. I pressed the on button and put in the SD card they gave me with the printer, had a few test files on it, put the first one in that I found, which was this tray, put their sample in, and then it went away and started printing. It first time laid around a little square of plastic and started going diagonally across. It was amazing. I watched the whole thing. It was like 3 hours. Probably not the most interesting thing to watch, but at the time it was incredible. And then eventually, this came out of it. As it went along a little bit here, as you can see the blob and pull up on the edge. Didn't know what that was at the time. I figured it out now. It's excess plastic came out, and the bed adhesion wasn't particularly good. Because at this point I was using masking tape to stick my stuff to the plate on. The next thing I printed was an upgrade for the printer. So I read around on Facebook, I've done a lot of research on this printer, and everyone says to do this, to print a new fan barrel. So there's a picture of it printing, that's the bit it's going to replace. That was it printed, and there it is having replaced its predecessor, which is a nasty little bit of printed cast and then reproduced plastic that doesn't quite fit in the hole it's meant to go in. It was only £130. It's since upgraded itself an awful lot more. I've got some spare upgrade parts at the back to look at if anyone wants to see afterwards. But there are some unprintable upgrades that I've had to get, because obviously it's quite cheap and it's not perfect. So this, for example, it's a slightly older version of the presentation. So this is a plug socket. I had never had any experience soldering before, so this was experience I enjoyed. I bought a soldering iron, which is fun. It was nice buying new things. I bought some solder, I bought this plug, I printed out a little case that fits around the power supply, because the power supply that this comes with, it's a cheap Chinese cable, it's a cheap Chinese socket that they give you an adapter to a European socket and they give you an adapter to a UK socket for, which isn't safe. And then the actual power supply itself has like this big open area at the bottom with like a little piece of plastic to, if you put your hand around there, you can get an electric shock, and UK mains is not nice. So I printed a little plastic cover for it, wired in this socket, and now it connects with a kettle lead that I borrowed from an old computer that doesn't need it anymore. And it's fused and everything, so it's a bit more safe than it was when I got it. Belts, the ones that gives you stretch, warp, not very good. These ones, fiberglass reinforced ones, they don't stretch and warp, so your prints don't look silly. It's very simple. A MOSFET. So this one's really important. This one was for the hotbed. So it's got the printer's, the hot end of the printer melts plastic. It gets quite hot, 200 degrees, but it's a really small part, so it doesn't have to work very hard. The hotbed, which is the bit that it prints onto, gets not as hot, but it's really big, so it draws an awful lot of current. And all of that current goes through the board on this. And I don't know much about electronics, but I do know they don't like getting too hot. So after reading online that some people have caught fire and turned into a big pile of molten plastic frame metal goop in their living room, they've had fire extinguishers around everything, I bought one of these. This is to stop that. The MOSFET, I never knew what one of these did before, but I now know that you put power in this end, power comes out this end, and it's regulated so it doesn't have to go through the board, basically. And then I bought this thing. It was a nightmare. It's an auto-leveling sensor. I thought it'd be great to not have to calibrate my printer with those really complicated tools every single time I wanted to do a print, but no, this was a lot harder. I had to install new firmware. So I'd never used an Arduino before, but the board comes with is basically an Arduino Mega. That Arduino Mega has a ramps board on top of it normally, but this is like a custom one, so it wasn't quite the same. I didn't realize it was an Arduino. So I had to install this. That went fine. Actually getting it to work, however, was a bit of a hassle. I didn't know how it worked. Is the video play?
Try another clip.
if anyone wants to see the video, I can show you afterwards. What it does is the sensor goes up and down, scrolls across 9 different points on the bed, and then gets rid of any waves and wobbles and all of that jazz, basically. The first time I turned it on and tried to calibrate it, it didn't sense the bed, and it went straight down and bent the bed, which was fun. So I had to straighten that out by taking it all apart and putting it back together again. The second time we were a bit more successful, but the bed was still bent, so the prints weren't going fine. But I got it there in the end, and it now goes along, does its thing properly. What's next? Well, I've gone through the ANET A8. I know how to melt plastic from a reel into a thing. There's loads of things at the back if you want to see them. I'm going to build a new printer, is probably the first thing. I've already printed all of the parts for it on the ANET, so there's a load of frame parts to print. I've bought from China an awful lot of electronics, some of which I don't know what it does. I just found the cheapest ones and hope that they work. In the next few weeks I'll know. And that printer will probably look like the one on the next slide. This is another thing that I intend to do. So everything at the back is just one plastic. Wouldn't it be nice to have multiple colours, or flexible and not flexible, or something or other? Well, I plan to do that with potentially one of these, potentially none of these. They're just options. This one here is called a diamond hot end. You put 3 plastics in, and it chooses which one to shove through the hot end, and hence you get that plastic colour. You can do RGB with this, but it's not quite as nice as it sounds. It's more like a painter's pot, where instead of mixing red and green to get a nice in-between colour, you actually just get mud every time. This is the official Prusa one, so the person who makes the printer and the open source design of the Prusa i3, which is what I've got. The ANET's a knockoff of. They've got like 4 different motors, and it's like this, but it retracts and puts it back in with a smaller, more cheap and readily available hot end. Or there's this design, which is really difficult to calibrate because you've got 2 dependent nozzles. But the printer I'm building is going to be one of these. This is called the D-Bot. It's a Core XY. It's going to be about twice the price of the printer I've bought, but it should be incredibly stable. The one I've got at the moment, when it prints particularly fast and it wobbles and it's got a motor on it, it just wobbles and wobbles and wobbles and makes the tops of the prints get an awful lot worse as it goes up. But this one, because it's a nice solid frame and it's not got a motor mounted on the bit that moves, it should be reasonably stable and give me a much better print quality. Yeah, thank you. But obviously I haven't gone into any technical, like what happens in this, but any questions for that would be welcome.
I have a question. Are you ashamed that the first thing that you printed wasn't either a cube or a shot glass? Because I believe that is mandatory for anyone with a 3D printer.
Well, I wasn't aware of this at the time. I just printed the first thing on the card they provided me with. The second thing that I printed was another thing on the card, which is a little statue of Big Hero 6.
Baymax.
Yes,
yeah.
Baymax.
Okay, you're forgiven.
It failed, but it was quite cool.
I have loads of questions, but I'll answer them later.
I have a question. So I saw you give this talk before and the conversation came up about 3D printed cheese. Are we there yet?
I'm not sure on 3D printed cheese, but there is definitely 3D printed pizzas, pancakes and chocolate.
Until there's cheese.
Until there's cheese. Unfortunately, not yet. I'll look into it for you.
Thank you very much.
How about pasties? I mean, Sophie might be quite interested in that technology.
We'll probably have one on pre-order.
Not sure how well the turn-up will go through, but there's only one way to find out.
Right?
Without attitude, you never will. Cool, thank you very much.